Hello everyone, welcome to this lecture in the Decision Trees from Scratch series. Today we are going to learn everything about Gini impurity. We'll also be looking at entropy, but most of the lecture will be focused on Gini impurity. If you are coming into this series for the first time, no problem. I have designed this lecture such that you can understand it. But I still recommend you to go through the previous two lectures in which we looked at how to or the steps to build a classification tree. Then we looked at some terminologies in the first lecture, such as root node, internal nodes, leaf nodes, etc. And we looked at the two types of decision trees, classification and the regression trees. In the previous lecture, we also started building a classification tree, and we started looking at questions such as how do we decide which question to be asked at the root node. So let me take you through what all we have covered so far so that everyone who has dialed in for the first time will also understand this lecture. So we are going to build a classification tree completely from scratch. And here is the training data which we are looking at in this particular endeavor of ours. So the training data consists of four categories: loves movies, loves cartoons, age, and then the final goal is to predict whether the person loves Batman or not. We have the training data of seven people and we have collected their answers. So for loves movies and loves cartoons, they have answered yes or no, and then we have recorded their age, and then we have recorded their responses to whether they love Batman or not. The goal is that, let's say, whenever any new person comes and you collect their answers to the first three questions: do they love movies, do they love cartoons, and what's their age? The goal is for you to predict accurately whether they will love Batman or not. As you can see, this is a mixture of discrete data as well as continuous data, and we will use this to predict if someone loves Batman or not. So, the best classification tree, or rather, the most optimal classification tree, which is the answer to this data set, actually looks something like this. The first question to be asked is: does the person love cartoons? If it's yes, we ask them, what's your age? If it's less than 12.5, then we can confidently say you do not love Batman. If they love cartoon and if their age is greater than 12.5, then we can confidently say that they do love Batman. On the other hand, if their answer to love's cartoon question is no in the first place, then we can confidently say they do not love Batman. And you can test all of this from this training data set. All the training data points will satisfy this classification tree. So this is the optimal classification tree. But the main question is, how do we reach this point? There are so many trees, right? There are so many options at every possible stage. How do we conclude that this is the best possible classification tree? And for that purpose, we have started building the classification tree ourselves. And the first question which we asked in the last lecture also is that what should be the question which comes at the root node? So this is the root node. What should be the question which comes here? How do we decide that we have to get started with this question in the first place? There are three options, right? We can either ask whether they loves movies or not. We can either ask whether they loves cartoons, or we can also ask for their age. So there are three options about how to get started at the root node. And today we will understand quantitatively how we choose the question to be asked at the root node. So let's get started. So, first, I want to compare between loves movies. This is the first question which can be asked, or loves cartoons. In the next lecture, I'm going to look at the age, because the age is a different, it's a numerical feature. So, today we are going to answer the question that among love movies and among loves cartoons, which question should be asked at the root node? Which question is the most optimal for classifying correctly whether the person loves Batman or does not love Batman? First, let's look at this flowchart. First, let's look at loves movies. And initially, let's look at all the people who have answered yes to this question. So, those would be all the people who have answered yes. There are four people. And then let's see how many of them love Batman or no. So, we can see out of these, three people said no and one person has said yes. So in this category over here, loves movies, yes, we have one person who has said yes, that they love Batman, and three people have said no, they do not love Batman. So I've written 1 and 3 here. If the answer to loves movies is no, which means I have this person, and this person, then let's look at the answer. Then we can see that two people have said that they love Batman, and one person has said that they do not love Batman. So we have two yes and one no. Now let us look at the same thing for loves cartoons. So if you look at Love's cartoons, I will mark it with a different color. If you look at Love's cartoons, we can say that one, two, three, and four people have said yes. And let's look at the answer. Out of these, one has said no, they don't love Batman, and out of them, three have said yes. So three yes and one no. That's what I've written here, three yes and one no. And let's look at people who have said no to loves cartoons. So if people who have said no, there is the first person here, the second, and the third. Interesting thing to note is that all the people who have said no to love cartoons, all of them don't love watching Batman. So there are three no's here and zero yeses. So there is zero yes and there is three no. Okay, so in the loves movies question, we have two leaves. We have leaf one and we have leaf two. In the loves cartoon question, we have two leaves. We have leaf number three and we have leaf number four. This gives us more information to decide which question do we ask at the start. So if you look at leaves number one, two, and three, they consist of mixtures of people who love and don't love Batman, right? Because if you look at leaf 1, we have people who have said yes as well as no. Leaf 2, we have people who have said yes as well as no. Leaf 3, we have people who have said yes as well as no. So all these three leaves consists of mixtures of people who love and don't love Batman. Whereas if you look at leaf number 4 does not contain a mixture because all of them don't love Batman. So there is a terminology here. Leaves which consists of mixtures of classification are called as impure leaves. So leaves 1, 2 and 3 consist of mixtures. They are impure. Leaf number 4 is pure. So in the loves movies question, there are actually leaves 1 and 2 and both of these leaves are impure. So in the loves movies question, there are two leaves which are impure. In the loves cartoons question, there is only one leaf which is impure. Now, the more impure the leaves are, it's difficult to classify, right, whether they love Batman or not. So, we should not ask that question. So, we should look at questions which lead to purer leaves. For example, Love's cartoon has a purer leaf. This leaf has, so okay, one leaf is impure, leaf number 3, but leaf number 4 is pure. All of them don't love Batman. This is great for our classification. So intuitively, we can see that Love's movies has two impure leaves, whereas Love cartoons has only one impure leaf. This means that the Love's cartoons question is more pure. So if we ask this question, we can very easily arrive to the final answer as who loves Batman and who does not. So intuitively, we know that we should probably choose Love's movies as the root. Uh, we should probably choose Love's cartoons as the root node, not Love's movies. We should probably choose Love's cartoons as the root node intuitively because asking this question leads to more purer leaves, right? But this is just our intuition. The main question which we are going to ask in today's lecture is how do we quantify this? How do we quantify the impurity in these two questions? So if we can assign a mathematical number to the impurity for the loves movies questions, and we can assign a mathematical number to the impurity for the loves cartoons questions, then we can easily look at two numbers, look at the question which has lower impurity and choose that as the root node. So today we are going to look at two measures to quantify this impurity. The first is Gini impurity and the second is entropy. So let us get started with understanding all about the Gini impurity. First, let's look at the first question, which is loves movies. We'll calculate the Gini impurity for this question, and then we'll calculate it for the loves cartoons. So loves movies, yes and no. It splits into two leaves, as we have seen. So loves Batman in the first leaves, yes is one, no is three, and loves Batman in the second leaf, yes is two, and no is one. First, we'll look at the mathematical formula for the Gini impurity and then try to understand a bit of an intuition. So, the Gini impurity for a leaf is defined as 1 minus the probability of yes whole square minus the probability of no whole square. Let me repeat that. The Gini impurity is defined for every leaf and it is 1 minus the probability of that node being yes whole square minus the probability of that node being no whole square. So there are two leaves here, right? There is the leaf number 1 and there is a leaf number 2. So the first thing which you should understand is that the Gini impurity will be defined for each leaf. So we'll have two Gini impurities. So let's first calculate the Gini impurity for leaf number 1. So we need two quantities. We need the probability of yes and probability of no. So let's look at leaf number 1. There is one person who has said yes to loves Batman and three who have said no. So the total number of people is 4 and the probability of yes is going to be 1 divided by 4 and the probability of no is going to be 3 divided by 4. Hence the Gini impurity for the leaf 1 is 1 minus 1 by 4 whole square minus 3 by 4 whole square. So if you do this computation, you will get that the Gini impurity for the leaf number 1 is 0.375. And now we'll be doing the same analysis for leaf number 2. For leaf number 2, there are two people who have said yes and one who has said no. So total number of people are 3. So the probability of yes is 2 divided by 3 and the probability of no is actually 1 divided by 3. So the Gini impurity of the second leaf is 1 minus 2 by 3 whole square minus 1 by 3 whole square. And if you do this computation, you will get the value of 0.444. So the Gini impurity for the leaf 1 is 0.375. Let me write it over here. And the Gini impurity for the second leaf is 0.444. In fact, I have even written it over here. Gini impurity for the first leaf 0.375 and Gini impurity for the second leaf 0.444. And now we want to compute a combined Gini entropy, right? We want to find the total Gini entropy for this question. So let's see how to do that. So four people have answered for the leaf number 1. As I mentioned over here, see yes is 1 and no is 3. So there are four people who have answered. In leaf number 2, there are only three people who have answered, 2 yes and 1 no. So to calculate the total Gini impurity, we will take the weighted average of the Gini impurity for both the leaves. So total number of people are 7 and out of those 4 have answered the first in the first leaf. So the first Gini impurity will be multiplied by 4 by 7 and the total number are 7 and out of those 3 have answered the second question. 3 have answered in the second leaf, right? So out of these 3 by 7 will be multiplied by the second leaf Gini impurity. So the first leaf Gini impurity, which is 0.375, will be multiplied by 4 by 7 and the second leaf Gini impurity is 0.444. That will be multiplied by 3 by 7. So the total Gini impurity will be 4 by 7 multiplied by 0.375 plus 3 by 7 multiplied by 0.444. So the total Gini impurity will be 0.405. Great. So the final conclusion is that the total Gini impurity for this question of Love's movies is equal to 0.405. Now, I had a section of visualizing Gini impurity here, but before that, let us actually calculate the Gini impurity for the Love's cartoons question. Now, let's look at the Love's cartoons and let's look at the decision map. If Love's cartoon the answer is yes, then the Love's Batman 3 say yes and 1 say no. If the Love's cartoon answer is no, 0% loves Batman and 3 say they don't love Batman. So this is the decision map. And let us find now the Gini impurity for Love's cartoons. And if you're watching this video, I request you to pause the video and do this calculation on your own because I've already shown you how to do this calculation for the Love's movies question and we are going to follow the exactly same thing. So for leaf number 1, let's see the probability of yes. So probability of yes is equal to 3 people have said yes and total number of people are 3 plus 1 which is 4. So P yes is 3 by 4 and P no is equal to 1 by 4 because one person has said no and total number of people are 4. So Gini impurity for the first leaf is 1 minus 3 by 4 whole square minus 1 by 4 whole square, which is 0.375. Now let's do for the second leaf. The probability of yes is 0 divided by 3, because overall 3 people have responded, and the probability of no is 3 by 3, which is equal to 1. So the total Gini impurity in this case is 1 minus the probability of yes whole square, which is 0, minus the probability of no whole square, so minus 1. So the Gini impurity for the second leaf is 0. So you should already think about this intuitively, right? The second leaf is completely pure, since all of the answers are in the no class, only one class. So that's why the Gini impurity of the second leaf is 0. Very similar to what we did for the weighted average in the previous question, we'll do the same thing. So there are four number of people who have answered the first in the first leaf, and there are three people who have answered in the second leaf. So the Gini impurity of the first leaf will be multiplied by 4 by 7, and the Gini impurity of the second leaf will be multiplied by 3 by 7. So the total Gini impurity will be 4 by 7 multiplied by 0.375 plus 3 by 7 multiplied by 0. Let me mark with a different color. And so the total Gini impurity is 4 by 7 into 0.375 plus 0, which is equal to 0.214. So the Gini impurity for the Love's cartoons question is 0.214. Now let us compare the Gini impurities of both these questions. Love's movies, we calculated the Gini impurity of this question to be 0.405, and for Love's cartoon, we calculated the Gini impurity to be 0.214. So we can see that the Gini impurity for the Love's cartoons question is actually lower than the Gini impurity for the Love's movies question. Now, quantitatively, we can say that Love's cartoons does a better job at classifying the people. So we should definitely prioritize this question over the Love's movies question. Earlier, we only looked at intuition, right? We saw that in the Love's cartoon question, one leaf is fully pure, whereas in Love's movies, there is no leaf which is pure. So we should probably ask this question first as compared to Love's movies. But now we have a quantitative framework. Mathematically, we have seen that the Gini impurity for Love's cartoons 0.214 is much lesser than the Gini impurity for Love's movies, which is 0.405. So mathematically, we know that when we construct the decision tree, when we build the decision tree, we should first ask the Love's cartoons questions. That is the advantage of this metric called Gini impurity, because it clearly gives us a framework for deciding which question to be asked while building the decision tree. Okay, so I hope everyone has understood the mathematical procedure for calculating the Gini impurity once you are given a decision tree. Now let us look at visualizing the Gini impurity. So, Gini impurity is 1 minus probability of yes whole square minus probability of no whole square, right? So, now let us consider a few scenarios. If the probability of yes is 1, then the Gini impurity will be 1 minus 1 minus then 0. Because if the probability of yes is 1, the probability of no will be 0. So, let me actually write this down. If probability of yes is equal to 1, then Gini impurity is equal to 0. Similarly, if probability of no is equal to 1, then Gini impurity is again, if probability of no equal to 1, then probability of yes will be equal to 0. So then Gini impurity will be 1 minus 0 minus 1 which will be equal to 0. So the first thing to understand is, if in a decision tree leaf, if the probability of either yes or no is equal to 1, then the Gini impurity is going to be 0. And the reason the Gini impurity is 0 in this case is because if the probability of yes or no is 1, which means that we don't have a mixture of classes. We either have everything in the yes class or everything in the no class. So that leaf is not impure, it is fully 100% pure. So that's why the Gini impurity will be equal to 0. Second thing which I want to mention is that, let's say there is a leaf, right? So let's say it's something like, if loves cartoons, right? And if yes, and then loves Batman, and let's say the it's structured such that the yes there are three people, and no also there are three people. Now this is the worst possible leaf because it's completely impure. The reason is because if you look at the probability of yes, that is 3 divided by 6, which is equal to half or 50%. And if you look at the probability of no, which is equal to 3 divided by 6, which is equal to half, which is equal to 50%. So basically, we should never ask. So here we can see that the yes is 50% or and no is also 50%. So we are not able to decide at all whether that person loves Batman or not. So we should not be asking that particular question. And this leaf is highly impure. Even if it's 40-60, then it's better because then we are more sure that it's a no. But now, if yes and no are 50-50, then it's like a coin toss. We are not sure at all whether it's a yes or no. So there is no point asking that particular question. And that's why if you look at the Gini impurity formula, right, and if you plot the formula, you will see that the maximum Gini impurity is obtained for a probability of yes equal to zero point 0.5 and probability of no equal to zero point 0.5. Let's see how to do that. So the Gini impurity is 1 minus P yes whole square minus P no. So let me say the probability of yes is equal to x, then the probability of no will be 1 minus x. So the Gini impurity, if you look at the impurity as just a function of x, it will be 1 minus x whole square minus 1 minus x whole square. And if you plot this, so if you plot x on the x-axis and Gini impurity of x on the y-axis, this function will look something like this. So let's see whether it makes sense. If the probability of yes is 1, Gini impurity is 0. So on the x-axis, I am actually showing the probability of yes. So if the probability of yes is equal to 1, we can see Gini impurity is 0. That's great. If the probability of yes is equal to 0, which means probability of no is equal to 1, then also Gini impurity should be 0, which is getting satisfied in this plot. And try to look at that point where the probability or where the Gini impurity score is maximum. You will see that the Gini impurity score is maximum for x. So which means the probability of yes is equal to zero point 0.5. So which means the probability of no is also equal to zero point 0.5. So if the probability of yes equal to probability of no equal to zero point 0.5, then the Gini impurity score is maximum, and that maximum value is zero point 0.5. So remember this, that if the leaf looks something like this, where yes and no are equal in number, then this is the most impure leaf because we are not able to decide which one is greater. So whether we should ask this question itself is debatable because if yes was 3 and no was 4, then also it's fine because then we know that the no is more preferred. So maybe many people don't love Batman, and that's why the formula is constructed in such a way that at x equal to zero point 0.5 the impurity score will be maximum. So this is sometimes asked in interviews that when is the Gini impurity score maximum. So keep in mind that it's maximum if the probability of yes and no is equal to zero point 0.5. And why is it maximum? Because at that probability, we are not sure whether asking that question is good or not, because it leads to both equal outcomes for both classes. So it's very, we are not getting any new information by asking that question. In fact, it's confusing. That's why a probability of zero point 0.5 leads to the highest Gini impurity score. And what is the highest Gini impurity score? That is equal to zero point 0.5. Remember, the Gini impurity score can never go higher than zero point 0.5. So if someone says they have attained a Gini impurity score of zero point 0.8, you should question that because it always uh, should be less than or equal to zero point 0.5. So this is the visual understanding regarding the Gini impurity score. As is done with all of these lectures, I first try to give a mathematical framework where I showed you how to calculate the Gini impurity mathematically, and then it is also very important to visually understand regarding the Gini impurity. And understanding this plot is very, very important for that reason. Most of this lecture was focused to Gini impurity. However, there is one more measure of impurity, and that measure of impurity is called as the entropy. I have seen both measures being used to quantify the impurity of leaves, but just the formula is different. So for the Gini impurity, the formula is 1 minus probability of yes whole square minus probability of no whole square, right? For the entropy, the formula is something like this: negative of probability of yes into log of probability of yes plus probability of no into log of probability of no. Again, the idea here is that if probability of yes is close to 1, which means that this will be 0. So remember that first of all, if probability of yes or no is 0, then this term will be 0. So if probability of yes is equal to 1, then it will be, so let's see, if probability of yes is equal to 1, then the entropy will be negative of 1 into log of 1 plus 0, because here probability of no will be equal to 0 if probability of yes is equal to 1, and log of 1 is anyway 0. So if probability of yes equal to 1, the entropy will be 0. Similarly, if probability of no equal to 1, the entropy is 0. This is the same as what we had obtained for Gini and Gini impurity, right? Probability of yes is equal to 1, the Gini impurity is 0. If probability of no is equal to 1, the Gini impurity is 0. So that is being satisfied in entropy as well. But just there is a log here which was not present in the Gini impurity. So now if you look at our same leaves over here, if you look at the first leaf in the loves movies question, so let's look at the loves movies question and let's look at the first leaf. So the probability of yes is 1 by 4 and the probability of no is 3 by 4. So the entropy would be negative of 1 by 4 into log of 1 by 4 plus 3 by 4 into log of 3 by 4. So then it will be 0.8113. And this is for the leaf on the left hand side for the loves movies question. And then for the leaf on the right hand side, the probability of yes is equal to 2 by 3, the probability of no is equal to 1 by 3. So then the entropy is given by follows: negative of 2 by 3 into log of 2 by 3 plus 1 by 3 into log of 1 by 3. So then this will be 0.9183. And so then the total entropy will be again the weighted sum. So there are four people here, and the total number of people are 4 plus 3, which is equal to 7. So the entropy of the first leaf will be multiplied by 4 by 7, and the entropy of the second leaf will be multiplied by 3 by 7, because there are three people. So then the total entropy will be 4 by 7 into 0.8113 plus 3 by 7 into 0.9183, that is 0.857. So for the loves movies questions, we get an entropy score of 0.857. As an homework assignment, I would really encourage all of you to find the entropy score for the loves cartoons question. If you have understood this, it's actually very similar formula. You just have to look at leaf number 3 and leaf number 4 and just look at the probability of yes and no in both of these leaves. Once you get that, you just apply this entropy formula and then take the weighted sum of both the leaves to find the total entropy of that question. Now, I have seen people using both entropy as well as Gini impurity. Both have their advantages and disadvantages. Maybe I'll cover that in a separate lecture. But right now, I wanted to introduce both of these methods to you to calculate the impurity score. And we have already seen that using Gini impurity, we have mathematically established that the loves cartoons question is much better. And I'm sure you will get the same answer with the entropy calculation as well. Now, if you plot the impurity versus entropy, both of these graphs look like this. On the blue is the Gini impurity, and we already looked at this plot over here. If you see, the Gini impurity again shows a maximum value of zero point 0.5, and the Gini impurity score is maximum for a probability P true is equal to zero point 0.5. It turns out that even the entropy index is maximum for a probability, for a true probability equal to zero point 0.5. So here you can see the entropy, and the entropy maximum value it takes is equal to 1. Gini impurity maximum value is zero point 0.5. But the x-axis, that is the probability of true equal to zero point 0.5, is the same for both of these metrics, and that leads to the highest it leads to the highest Gini entropy, and this probability of true equal to zero point 0.5 also leads to the highest entropy. And I think you should start looking at the intuition for this. So if P true is equal to zero point 0.5 and if P false is equal to zero point 0.5, then essentially we are not sure at all, right, which way we are going. Does the person love movies or not? It's 50% probable. And that's why this leads to the highest entropy, and that's why this leads to the highest impurity. One way to think about entropy is also disorder. So if P true is equal to 1, which means we are really sure that the person loves movies. If P true is equal to 0, then we are really sure that the person does not like movies. So then the entropy starts reducing here and the entropy starts reducing here because the level of disorder is decreasing. But as the P true becomes equal to zero point 0.5, so let me mark it with a different color. So as the P true becomes equal to zero point 0.5, which means as we start going here, then you can see the entropy is really increasing because then the disorder is increasing since we are not really sure whether the person likes the movies or not. So please keep in mind, because this is also asked in interview questions, is that Gini impurity and entropy both take their maximum values at a P true is equal to zero point 0.5. Please do keep that in mind. But the entropy maximum value is equal to 1 and the Gini impurity maximum value is equal to zero point 0.5. Okay, so in this class, we have actually achieved the objective which we started out with. We looked at these two questions, right? We looked at these two questions, and we wanted to decide which is the question which we should start with in the decision tree. And now we have decided that it should be love cartoons, and we have a really good idea for it. And this matches the optimal decision tree which I showed you at the start. But there is one more thing which I have not addressed. You might be thinking, what about age? We saw that love's cartoon takes precedence over love's movies, right? But what about age? Why don't we start with the age? Like, okay, love's movies is not good as love's cartoons, right? But what if I start with age and then do the branching later? So it turns out that computing Gini impurity for age is completely possible, but it is a bit tricky because age is the numerical data and it's not just yes or no. So in the next lecture, we'll actually find out how you can compute the Gini impurity for age also, and then we'll compare Gini impurities for age, for loves movies and loves cartoons, and then finally we'll quantitatively establish why we have to start with the loves cartoons questions. Loves cartoons question. So I hope everyone you got an understanding of the Gini impurity and the entropy score in this lecture, and you have also looked at the visual representation of the Gini impurity and entropy. One graph which you have to keep in mind at the end of this lecture is this graph where we have shown Gini impurity and entropy in one single graph, because that will also help you for your interview preparation. As always, I am keeping these lectures a mix of theory, whiteboard writing, and also visualization, so some practical implementation so that you get clarity. And unlike other lectures, I am actually showing you how to build the decision trees completely from scratch. Of course, we'll get to Python coding later, but first you need to really understand these concepts. This is the same approach we followed in the neural networks from scratch series on this YouTube channel and the machine learning teach by doing. So thank you so much everyone for sticking with me until this third lecture, and I'll see you in the next lecture.